Okay, this is the recording of my online class. Okay, in a previous section, we solved these MCQs in until quiz 12, and now we start by quiz 12 and we proceed. Okay, so I repeat that the student will be asking me some questions, but I will keep the flow of the stuff. I will repeat the question in such a way that any people watching this video will be able to understand what was the question, and I think all the stuff will remain current. Okay, nice. So quiz number 12. Given the function f of x equal to x squared times the logarithm of x, which of the following stuff is true? We go on the board. So we have f of x equal to x squared times the logarithm of x. Okay, just a moment. The problem is that I forgot to share my screen before the lecture. Okay, and now? Okay. So we have f of x equal to x squared multiplied by the logarithm of x, and what is the first thing is that f of x has an horizontal tangent point at x0 equal 1. I remind you that an horizontal tangent point is a point where the derivative is equal to 0. Okay, so horizontal tangent point, okay, corresponds to a point. So if I say x0 is a horizontal tangent point, it means that f prime of x0 is equal to 0. And thus, in this exercise that says that f of x has an horizontal tangent point at x0 equal 1. It means that f prime of 1 should be equal to 0, right? So let's prime f prime of x. F prime of x is 2x multiplied by the logarithm of x plus 2x multiplied by plus x squared, I mean, plus x squared multiplied by 1 over x, right? So it will be 2x log of x plus x. Is that clear? Okay, so this is now f prime of 1 will just be 2 multiplied by 1 multiplied by the logarithm of 1 plus 1. Thus it is 1 because the logarithm of 1 is 0. So 1 is not an horizontal tangent point, right? Now the tangent line to the graph of f of x at 1, 0 has equation y equal to x plus 1. The tangent line to the graph of f of x at 1, 0 has equation y equal to x plus 1. So as the point is 1, 0, it means that x0 is 1, right? So we remember that the formula for the equation of the tangent line is y equal to f of f prime of x0 multiplied by x minus x0 plus f of x0. So we will have y equal to f prime of 1. We just compute f prime of 1, but let's write the formula x minus 1 plus f of 1. So equal to f prime of 1, that was 1 multiplied by x minus 1 plus f of 1. But if one compute x of f of 1, f of 1 is 1 multiplied by the logarithm of 1, so it is 0. So this is plus 0. So the equation of the tangent line is y equal to x minus 1, but they gave us y equal to x plus 1, so b is false. The Taylor expansion of f of degree 3 centered in x0 equal 1 is f of x equal to this stuff. You see here they want us to find the Taylor expansion of degree 3. It will take some time to compute it, right? So probably it's better to check if the other stuff are false or true. So we go on the board and we say, so for example we can find the third derivative at 1 or find the second derivative at 0, right? So let's find first the second derivative. F second of x will be equal to, it means the derivative of the first derivative. We found the first derivative here. The derivative of the first derivative was 2x multiplied by ln x plus x. So let me first write here the first derivative. F prime of x was 2x multiplied by ln x plus x. So f double prime of x will be 2 ln x, okay, plus 2x multiplied by 1 over x plus 1. That will be equal to 2 ln x, okay, plus 2 plus 1, so equal to 2 ln x plus 3. This is the second derivative of x. Thus the second derivative at 0 does not exist. Yes or not? It doesn't exist because you cannot do the logarithm of 0. Now let's find, so we understood that also c is false. We remain with d and c. So we go back and we do the fourth derivative at 1, okay, and we directly see that the fourth derivative at 1 is no, first of all we need to do the third derivative, okay, at x. It means the derivative of this one, so it will be 2 over x plus 0, right? So the third derivative at 1 will just be 2 over 1. Yes or not? That will be 2, and so d is correct, right? And if you want to know why this guy is false, you have all the stuff to check if this guy is false, because we know that f of 1 is 0, f prime of 1 is 1, f second of 1. How much is f second of 1? If you put f second of 1 will be 3. Yes or not? And f triple prime of 1 is 2. So if you want if you write the Maclaurin the Taylor expansion, it will be f of the Taylor expansion is f of x equal to, we will first write f of 1, which is 0, right? Then plus, so we have 0 plus f prime of 1, which is 1. So it will be 1 multiplied by x minus 1 plus the second derivative, which is 3, so plus 3 over 2 multiplied by x minus 1 square, plus the third derivative, which is 2 over 6. Yes or not? 2 over 3 factorial, which is 6 multiplied by x minus 1 cube plus liter o of x minus 1 cube. If you check this Maclaurin this Taylor expansion is not the same because we missed the first day, the part of the first day. Yes or no? Okay, so this concludes the quiz number 12, and the answer, as we said, was 12D. Okay, now we move to the MCQ, the one that follow, that is the MCQ 13. Okay, so you are given the function f of x equal to sine square of 2x. Which of the following is true? Okay, so let me clean the board and sort it in such a way that okay, so we have the function f of x equal to sine square of 2x. The question is the Maclaurin expansion of order 4 of f of x is 4x squared minus 16 over 3 x to power 4. Okay, f of x has a relative maximum in x equal 4. F of x for x tending to 0 is infinitesimal of order 4. Its principal part for x tending to 0 is p of x equal to 4x squared, and the second derivative at 0 is equal to 0. Let's try to, you see that in order to answer to the first one, or in order to answer to most of them, we need the Maclaurin expansion of the function, yes or not? So we try to write down the Maclaurin expansion of this function. By studying, you observe that the function is sine x, the sine of 2x multiplied by sine of 2x, yes or not? Because it is sine square. But as we know that sine of 2x, it is the sine of quantity. Sine of quantity, if the quantity tends to 0, we can apply the trick. In fact, the quantity here is 2x, and x is tending to 0 because we have we are doing the Maclaurin expansion. So it will be the quantity, okay, we need the Maclaurin expansion of order 4 plus the quantity cube, that's 2x to power 3 all over 6, and it's minus here for a sign. So this minus. Now if I continue, if I expand again, I will have to do plus the quantity to power 5, but this is too much because I need only order 4, right? So I just write plus little of x to power 4, right? Now this is just for one, so for the sign we can write it like 2x minus this will be 8x cubed over 6 equal to 2x minus 4 over 3 x cubed, right? But the function is not just sine of 2x, it is sine of 2x multiplied by sine of 2x. So my f of x will be 2x minus 4 over 3 x squared multiplied by 2x minus 4 over 3 x squared, right? X cubed terms. And thus you will get 4x squared minus 8 over 3 x4 minus 8 over 3 x4, but the last term is useless because it will be x power 6, but I don't need it, so this is plus little of x4. That it will be up to 4x squared minus 16 over 3 x4 plus little o of x4. This is the fourth order Maclaurin expansion of this function, right? So I remind that here the formula that we use is the fact that the sign of quantity is equal to quantity plus quantity minus quantity cube. Here is minus quantity cube over 6 plus quantity 5 over 5 factorial, okay, and so on and so forth, right? With the condition that the quantity should be tending to 0. Is that clear? And that's our quantity was 2x, so we do quantity minus the quantity cube over 6, and then we stop. So now, is there any question? But because we stopped at the cubic because we needed the expansion of order 4, okay? Okay, first I repeat the question of my student. The question of my student is why when we expand the sign, when we did sine of 2x, why the second order and the even order didn't appear? The even order didn't appear because the formula of the sign, the expansion of the sign, then it's like this. Is that clear? Is that clear? Okay, nice. Let's go back on the PDF to see which one of the answer is the correct one. So the answer says that the Maclaurin expansion of order 4 is 4x squared minus 16 over 4. Is true or false, this one? No, it's not true, because this is a polynomial. Why is the letter O? So A is not true because there is not the letter O. Okay, the Maclaurin, here we need the expansion, but here they give me just the polynomial. Even if this is the polynomial we got, but it's not the Maclaurin expansion. Okay, has a relative maximum in x equal to 0. Let's go and see. No, because we get f of x is equivalent to 4x squared, right? 4x squared means that it is like this, like x squared, right? So it's a relative minimum. And then so B is false. F of x equal f of x for x tending to 0 is infinitesimal of order 4. We can see that f of x is equivalent to 4x squared, right? So this is infinitesimal of order 2. Is that clear? The order of the polynomial that approximates the function is 2. It's an infinitesimal of order 2. Its principal part for x tending to 0 is 4x squared. Yes. Yes or not? The principal part is exactly 4x squared. I remind you that the principal part is the most important term of the Taylor expansion. Okay? And here, for this Taylor expansion, the most important term is this one. So it is the principal part. So D is correct. The answer is, in fact, 13D. Okay? And they are saying that the second derivative at 0 is 4. Let's go and check. The second derivative at 0 is 4 is not true, because in the Maclaurin before x squared we have 4, right? But the formula in the Maclaurin in the formula we know that before x squared we should have the second derivative at 0 divided by 2 by 2. Yes or not? Because in the Maclaurin, I remind that the Maclaurin expansion is f of x equal to f of 0 plus f prime of 0 multiplied by x plus f second of 0 divided by 2 multiplied by x squared. So when I find the Taylor expansion, the number that is before x squared is the second derivative divided by 2. So we have but what we got is that we got 4x squared. So here in our expansion, x squared go with 2, but x squared is expected to go with f prime, the second derivative at 0 divided by 2. So we got that the second derivative at 0 divided by 2 is equal to 4, right? And so the second derivative at 0 is equal to 8. Doubts? Okay, so okay, this concludes the quiz number 12 and 18, and we will continue with the solution of the quiz number 14 and 15 in another recording.